Hi everyone, now let's talk about types of triangles and their properties. Okay, this is a brief recall for my students who were absent, and as I said before, I don't want to leave anyone behind. And let's start with types of triangles, okay? And as I said in class, a triangle is a three-side polygon, okay? Something that looks like this, has three, okay, triangle. So it's a three-side polygon. So this is what we mean by triangle in the Euclidean geometry. So the first type is equilateral triangle, okay? Has three sides, three equal sides, okay? So something that looks like this, okay? And we use those dashes to prove and to show that is an equilateral triangle, and it has also three equal angles, okay? Which means, for example, x, 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 and we are going to prove that it's exactly each one of those measures exactly 60 degrees, okay? 60 degree, okay? And the second type is isosceles. So it's not isocel, please. It's isosceles triangle that has two equal sides, only two, okay? So it's something that looks like this. And we use these dashes to show that is an isosceles triangle, and this side here called the base, okay? And those two angles here called the base angles, okay? Because they share this arm here as a common arm. And finally, if there is nothing special, and I mean by nothing special, three different angles and three different sides, so we call it scalene. So it's not scalene, please, it's scalene, okay? Scalene triangle, and we mean by that nothing special. So no sides are equal, no angles are equals either, okay? So this is the basically three famous types of triangles, and actually we have two ways of classifying triangles. We can classify triangles by side, so we can talk about equilateral, three equal sides. We can talk about isosceles triangle and scalene triangle, and we have second classification using angles. So if, for example, your triangle has three acute angles, we call acute triangle, so that's obvious. And let's say we have here, we use the square box to show that it's a right angle. So if it has one and only one, of course, right angle, you can call it right triangle. And if it has one obtuse angle, so we can call it obtuse triangle. But most of the time we use only those two, the first classification, which means classification by side, okay? Equilateral and isosceles, okay? So here I'm mentioning something important. In mathematics, you can't use your eyes. No matter how beautiful your eyes are, you need to use proofs. So let's say you have here this amazing, spectacular triangle. So it looks like isosceles triangle, but you can't say that. Okay, so we need to prove it. So the first way, or the first method, is to give measures. So let's say that this side measures, for example, 3 meters, and this one also 3 meters. So this is a proof that this triangle is isosceles triangle. Second way is to use dashes, les traits in French. Les traits, ça c'est A. Okay, les traits, dashes, not dashes, dashes. Okay, what I mean by dashes, something like this. Okay, it's a small dash that we use to show that those two sides are equal. So this proves that we are talking about isosceles triangle. And I am adding here some pictures just to show you that these two sides here are equal, and also this side and this one are not. Okay, using same dashes means we're talking about the same side length. Using different dashes, this means we're talking about different sides lengths. Okay, so this one is an equilateral triangle, and the proof is the three same dashes. So this is for sides. Okay, for angles we don't use dashes, we use arcs, les arcs in French, something like this. So let's say, for example, we have here two angles. So if you are using the same arcs, this means those angles have the same measure, okay, which means same size. And for the right angle, we use this square box, the famous square box, to show that this angle measures exactly 90 degrees. Sorry, I'm a little bit tired, so maybe my voice is not that clear and my English just rocks, but I'm doing my best. So now let's move to, so this is definition part. Now we are going to talk about properties. Why properties? To prove, good, to give a reason of your calculations. So 7 minutes, that's fine. So the first property is the sum of all three interior angles in any triangle is always equal to 180. As you can see here, we can use this GeoGebra tool, as I showed you in class, just to make sure that indeed the three angles add up to 180. So let's say, for example, that this point B has nothing to do in life, so she decides to keep moving like this. So no matter how I change the position of that point B, the sum remains indeed 180. Even if I change, for example, C, even if I change it so it looks like the straight line, or here, what if I change point B? So this GeoGebra tool really is interesting, just to prove actually that it's 180. So this is the first property, and we use that and to, for example, let's say here 630, for example, here 60, and I want to calculate x. So x is 180 minus 60 plus 30. Okay, so this is just the calculation part. You need to justify your calculations, and we will see how, the structure of your reasoning in the problem solving video. Okay, but this is the main structure. Okay, we start with language. Okay, we know that the sum of any triangle angles is 180. So logical connectors, the first one, let's say for example here A 40 degree, and here we have 60 degree. This is just a sketch. Okay, I'm just sketching, it's not exact. Un figure à main levée in French. So A is 40 plus 60, and it equals to 180. So I'm subtracting the sum of the two known angles from 180, and finally I'm closing the proof now. I'm going to talk about structure of reasoning because it's important. E equals to 80. Okay, so the second one is the isosceles property that says that the base angles are equal. So it's very simple, so please remember this. In any isosceles triangle, the base angles are equal. By base angles, I mean les angles de base in French, this one. So, but you have to make sure that you are talking about isosceles triangle. Okay, so we have, for example, 2x, okay, x plus 40 add up to 180, because the sum of three angles in a triangle is 180. So 2x is equal to 180 minus 40. Okay, so that is 140. So x is equal to 140 degree divided by 2. Okay, and that is 70. And we can use here so, and here, for example, therefore. Okay, therefore is like finally or indeed. And the last property is, at any triangle, the measure of an exterior angle is equal to the sum of the two remote interior angles. Let's say, for example, we have here a triangle. So this exterior angle here is equal to the sum of the two remaining remote interior angles. Okay, so we're not talking about this one because it shares this vertex with the exterior angle. Okay, so you can't use that. So you use those two opposite remaining angles. Okay, so for example, here x, here e, for example a, and here b. So e equals to e plus b. Okay, so this is important, and we will see some examples in the problem solving video. Okay, so I was a little bit tired, but I decided to share these two videos for you, especially for those who were absent, and I hope that my explanation was clear. And if you have any question, of course, ask me at class or in the comments. Okay, have a great day.